So today we're going to look at a special type of sequence. It's called a arithmetic sequence. Now, arithmetic is like adding and subtracting. So all of the math that you did in grade school, that was like arithmetic. And so this sequence has to do with adding and subtracting. And so what is this sequence? Well, it's a sequence in which the difference between any two of the terms is constant. Meaning, I'll show you an example here. Take a look at this sequence: 5, 8, 11, 14, 17. Notice the difference between the first two terms. 8 minus 5, that's 3. 11, 11 minus 8, it's also 3. 14 minus 11, also 3. 17 minus 14, also 3. And so from one term to the next, it changes by 3. And so in this type of sequence, we want to find this variable d. How much does it change? And here it changes by 3. And if it's constantly changing by the same value, then it's an arithmetic sequence. Or an arithmetic sequence. And so here's some examples. We've already looked at this first one. Take a look at the second one. The question is, well, determine if the sequence is arithmetic. And, okay, well, let's see. 16 minus 23. That's going to be negative 7. And so this one's going down by 7. To get from 16 to 9, you go down 7. To get from 9 to 2, you go down 7. And so as the sequence increases, as the numbers move on in the sequence, they get smaller. And so the difference is going to be negative 7. This one, it increased by 3. And so the difference, that variable d, was positive 3 because it increased. And if you needed to give the next three terms like this is asking, well, let's take a look at 2. Well, if we're here at negative 5, the next term would be you just subtracting 7, which would be negative 12. And then the next term would be you subtracting 7 again, which would be negative 19, and so on. Take a look at this one. The question is it an arithmetic sequence? So let's see. From 1 to 2, we increased 1. From 2 to 3, we increased 1. From 3 to 5, we increased 2. And so we could stop there because, no, it's not an arithmetic sequence. It doesn't increase or decrease by the same value. Take a look at this one. This one's going down 2, down 2, down 2. So, yes, this one is. Okay. How about this one? Yeah, no, it's not. This one goes... well, it goes up 10, and then up 5, and then up 5, and up 5. So no, it's not. And so, like, you can have this general formula for an arithmetic sequence. The general formula, and this is all available in on Schoology, like all these formulas and stuff. It's available on the student solutions in that Unit 10 folder. So if you want to find the nth term, meaning maybe there's an infinite amount of terms in this sequence. If you want to find the 10th one, then n would be 10, right? So no matter what term you're trying to find, the nth term, you can use this formula. A sub n is just meaning this is the nth term. So like if we're trying to find the 10th term, this would be a sub 10. And so here's the formula. If you find that constant, that variable d, by which all of the terms are changing, then you can find any term by just multiplying d, the amount that it's changing, by n minus 1. So for example, if we wanted to find the 10th term, we would, let's say it's going up by 2 every term. We would do 2 for d times 10 minus 1, which is 9. And then we would add that to a sub 1. A sub 1 is the first term. And so this formula will work every time, but only for this type of sequence. A sub 1 is the first term, and d is the common difference. So for example, write a rule for each sequence and then find the indicated term. Okay, let's see. Well, we can write a rule here. Well, let's first identify that it is an arithmetic sequence. Let's see. From -5 to -1, that looks like it goes up 4. -1 to 3, up 4. 3 to 7, up 4. And so D is 4 here. What's A sub 1? The first term? Well, it's -5. And so we can write this formula for this sequence. A sub n, any term, the nth term is going to be 4 times, because D is 4, 4 times n minus 1. Now we need n to be a variable here, because this is a formula for the nth term, meaning we can find any term. And so leave n as a variable. But we need to put the first term in here. So A sub 1 is -5, so we've put it here. And then you can simplify by distributing the 4. You get 4n minus 4 minus 5, and you can combine your like terms. So this would be 4n minus 9. This here is the formula for this specific sequence. And so first you need to identify, is it an arithmetic sequence? And then you need to identify the difference, like what's the amount that it's going up or down as we increase in terms, and you need to identify the first term. Then you could write the special formula for the specific sequence, and then you can find anything you want. And so what does this one say? Find the indicated term. Oh, so here off to the side, they asked us for A sub 24. That's the 24th term. And so we could find that using the formula we found. We just plug in 24 for n. 4 times 24 minus 9, and this is the 24th term. Take a look at some of these other examples. Actually, here, let's look at this one. So they don't need to be whole numbers. Looks like this one is going up by 1.5 every time as you move from one term to the next. And so, you find the formula the same way. And okay, yeah. One more thing. Okay. Now remember, a series is different from a sequence, because a series is the sum of the sequence, meaning you add up all the terms in the sequence, and that's what the series is. It's the sum of all the terms. And so we have another formula for you to find S sub n. That's just saying the sum. S sub n is the sum of the series with n amount of terms, n terms. And so the total sum is going to equal n times. So like if you're looking for the sum of the first 10 terms, S sub 10 would equal 10, because n would be 10. 10 times the first term, A sub 1 is the first term, plus A sub n. So whatever term you're landing on, in this case would be the 10th term. If we say that we're looking for the sum of the first 10, you would add the first term, the 10th term, divide by 2, multiply by 10, or the number of terms in the sequence. And so yeah, n is the number of terms, A sub 1 is still the first term, and A sub n is the last term. And so this is for a series. And so you need to pay attention to whether or not it's a sequence or a series. Let's look at an example. Directions. Find the indicated sum for the arithmetic sequence or series, not sequence, series. And so let's see. Here are the terms, right? So it goes 2, 4, 6, 8. And so S sub 10 means we want to find the sum of the first 10. And so we could use this formula here. Notice it increases by 2 going from one term to the next, which means it's an arithmetic sequence. And so if we find the sum of the first 10, we could use this formula. Plug in a 10. A sub 10 equals n. Wait a second. Oh, I see. Oh, yeah. So look, they needed to find the 10th. They needed to find the 10th term because we're using the last term. So first you need to find the 10th term. And so you could use you could use this other formula to find, this one here, d times n minus 1 plus the first term. You need to find that term. And so since these are going up by 2, d is 2, which means that a10 is going to equal 2 times, what was it? 2 times, n minus 1. 2 times n minus 1, okay, n is 10, okay, 10 minus 1 plus 2, which was the first term. And so a10 is 20. And so now that you have the last term in the sequence, you can find the sum. S sub 10 means, hey, let's find the sum of the first 10. And so using this formula, 10, because n is 10, 10 times the first term plus the last term, so 2 plus 20, which is the last term, divided by 2. Multiply all that by 10. You'll get that the sum is 110. Let's look at another example with some different notation. So this sigma notation is sum. This means sum. And so what it's saying is, hey, add up all of these values from x equals 1 all the way till x equals 12. And so since this expression here is our sequence, a sub 1 is going to be us plugging in a 1 for x. And so the first term here is us plugging in a 1 for x. 6 times 1 is 6, minus 4 is 2, so the first term is 2. And a sub n is the last. Remember, that's the last term. And since they want us to sum from 1 to 12, they want us to find when n is 12. And so a sub n, well, if n is 12, well, in this case, x is 12. So, pay attention. I know it gets confusing because x is sort of like n here. So we just need to plug a 12 in for x. 6 times 12. 6 times 12 minus 4, so like 72 minus 4, which is 68. Now we have the first term. We have the last term, which is a12. And now we can find the sum using that formula. The sum of the first 12 equals 12 times the first plus the last divided by 2. And the sum of all that's going to equal 420. And so it's just a different example for you. All right, you'll find the homework in the assignment. Thank you. Hope all is well. Bye-bye.